Hey, so my name is Drew Hannay. I work at LinkedIn. I'm the tech lead for our flagship Android app, the one you're probably all familiar with. I've been at LinkedIn for almost 3 years now. It'll be 3 years in September. So I'm going to start off today by telling you a little bit about what our process of releasing the LinkedIn app was like when I joined LinkedIn 3 years ago. So if I jump here, this was our ideal release schedule when I joined LinkedIn. We had 12 releases per year, so once a month we would go through this process where on Friday we would cut a release candidate build. It would get sent off to our testing team, and they would spend the weekend and Monday and Tuesday going through an enormous manual regression suite. They had a whole list of things that they would validate we're still working with our new build, with all the new code changes. And then the release would go out on Wednesday to production. We have on-call developers at LinkedIn, so once a week, every Thursday, we'll switch over. A developer will be responsible for any issues that come up in production or with the release candidate. So the schedule fit in nicely with our on-call shifts, and they would, if you were on call during a release week, you'd be responsible for following up on any issues that the testing team found during their manual testing. So note that this says ideal at the top of the slide. In reality, what would happen would look something more like this. The Wednesday and Thursday before our release candidate build, we would have all of our probably 50 to 100 devs that work on the app would be rushing to check in code, because if they missed this release candidate cutoff, it was another month before their changes would get out to production. So then we'd start our manual testing. Often, or more often than not, there would be a bug found that needed to be fixed. So we would get the bug in, we would do a hotfix and get another release candidate build for them to continue testing. And then often a product manager would come and say, wait a second, I didn't realize that my feature that we have all this marketing planned around didn't make the release candidate build. We need to cherry pick this feature. We can't wait another month to release this. It's going to cost the business a lot of money. It's super important. So we would get that in. But now that feature went in on Tuesday, so we can't really, in good conscience, do our release on Wednesday because it hasn't really been tested. So we would delay the release for another week, switch off to another on-call who has to now go learn everything that happened in the past week and be ready to take it on for the next week. We'd do some more manual testing, find some more new bugs in that new feature that got pulled in at the last minute, and eventually, if we're lucky, get a release in a week later. And you would just pray that you were not on call this week. And we still just had 12 releases per year. With this schedule, really nobody was happy. The devs weren't happy because those nights before the release candidate build, they would be up till 2 or 3 in the morning trying to get their code checked in, trying to beg somebody to get a code review so they could get their code checked in, without test cases, without proper vetting of their code. They didn't want to be on call. The product managers weren't happy because they only got 12 releases per year, which is really not very many to work on new features. It's hard to iterate on member feedback, so we would spend a ton of time making these huge bets on features that we had to get right the first time because we didn't release often enough to get good production feedback and continually improve our product. The testing team certainly wasn't happy because they spent all this time manually testing. The code quality would take a huge nosedive right before the release candidate builds because everybody was prioritizing making the release over finishing their feature. And the leadership wasn't happy, mainly because everybody else wasn't happy, but also because we couldn't iterate quickly as a business, which these may sound like technical issues, but they're affecting LinkedIn as a company, so we needed to do something about it. So right about the time that I joined, we were starting on Project Voyager, which was released 2 years ago in November, so almost 2 years ago. But this was, from a product perspective, it was a reimagining of our flagship product. Brand new design, new set of functionality. It was a brand new code base on the engineering side for both iOS, Android, mobile web, and for our front-end API server. So we had this opportunity where we were starting from scratch, essentially. On the product side, in addition to the actual product changes, they wanted to move to weekly releases. That was the product requirement for release cadence. They wanted the ability to have more iteration, do better experiments, do better iteration on member feedback. And around this time, mobile was becoming more and more important to LinkedIn. It was becoming more of our traffic, more of our revenue. So we needed to get better at mobile. So that was getting better at mobile, getting better at releasing was one of our big guidance on the engineering side as we started this rewrite. So the easy engineering answer is it was weak the whole time. We just need to get better at it. So in our ideal world, we could do weekly releases. We had the time for manual testing. Luckily, if LinkedIn has smarter engineering leadership than to propose this. The real goal, so they said, okay, yes, we want to do weekly releases, but release cadence should be a product decision. They should be able to decide they want to do 3 releases per week or 2 releases per week, and we shouldn't have limitations on the engineering side. We should always be able to take the latest build that has gone through our CI pipeline and be able to give it to some set of members. But that doesn't mean we can spend 24 hours on our CI pipeline running thorough tests. So the biggest thing is this was a big mindset shift for the entire organization. We have, I pull this number regularly, and it's always different, but over the last 3 months, we had almost 200 people check in code to our Android code base, and I think 50% of those people had less than 2 commits. So we have a wide number of people contributing to the product, so it's hard to get everybody on the same page, and we needed a big mindset shift. So the catchy slogan that our leadership came up with was called 3x3. So the goal being, we want to release 3 times per day with no more than 3 hours from the time that you commit the code to the time that it is available to some set of members. The important thing to remember here from an Android and iOS perspective is that obviously we can't release to Google Play and iTunes 3 times a day. But our employees are members too. We have a lot of employees that are not developers. We have salespeople, we have marketing people. We certainly can force them to update their app 3 times a day. So why was 3 hours picked? A very intentional step was that 3 hours is not enough time to have manual testing. You could try to hire somebody to do the same manual testing 3 times a day every day of the week, but you probably wouldn't find anyone, and if you did, they would probably quit pretty quickly. It's also not enough time to test everything, which this is the one that usually people are surprised by, and this is a very intentional choice. We're not trying to have 100% automation. Our goal here is to be able to iterate more quickly on our product. We had seen cases where we want to move to 100% automation, and now we have so many tests that every time the product wants to make a big change, half of our time is spent updating tests or rewriting tests or just fixing tests that now don't make sense anymore. So we're not trying to hit 100%. We're trying to figure out how do we write tests that make sense and provide the highest value with also the lowest maintenance cost. And like one of LinkedIn's core engineering principles, or one of the ways engineers are evaluated, are three aspects: are leadership, execution, and craftsmanship. With craftsmanship being one of those core pillars. This lets devs take the extra time to write quality code, because if they miss this release, the next one's only 3 hours away. So there's no need to rush to get code in. It also is easy to fit 3 releases in a day, so 10 a.m., 1 p.m., 4 p.m. And so for the rest of this talk, I'm going to go through, this is what our commit pipeline looks like. And the highlighted parts here are the parts that need to fit into our 3x3 timeline. So obviously, feature development code review, that's our normal process that developers go through. From the time that they commit their code, there's the things that run through our CI pipeline, essentially, is what this is. And so I will start going through these. Static analysis, and for what it's worth, I'm going to go through at a fairly high level at all of these. A lot, yes?
So some of these tests, do you like parallelize them, or is it a true pipeline?
Yeah, so I will cover that as well, how some of this is parallelized and how we make all of these things fit into the time period that we are looking for. And I'm going to go through at a fairly high level, but we can have questions at the end as well. So for static analysis, we run check style on all our Java code. We enforce everything as an error. So this was a nice thing about starting from a clean code base. We could enforce no check style errors from day one. We rely super heavily on lint. This is one of the biggest advantages that we have on the Android side over the iOS team, is that we have the 300 and growing checks provided by Google. We also can use the lint framework to write our own custom checks, and we've already written roughly 50 of those for LinkedIn-specific bugs or best practices or ways of using our internal libraries properly. The other thing that's given us a lot of safety and ease of mind is that with our front-end API server, we're using LinkedIn's RESTly framework, which is basically a way for our API server to define the models, the response models that they're going to send. And we can use that to co-generate the classes on Android, iOS, and web that we use to parse those responses. This means devs aren't worrying about parsing JSON. On the API side, anytime they make a change to an API, they get full backwards compatibility testing to know if they're accidentally adding a required field that they shouldn't or removing something that old clients might be using. We're also on the Android side experimenting with auto-formatting the code with the new command line formatter from IntelliJ. Jury's still out on how useful this is and how this performs, but this is something we're trying to play with because we're trying to figure out how to spend less time in code review on style things altogether and make sure just the code is completely formatted the way we expect. So for building the code, like I said, we started this whole process with a new code base, so we didn't have that much code. And initially, it took about 5 minutes to do all of our builds on CI, and that was great. Today, just the debug build, it takes 8 minutes. And I think that's actually the debug plus the test build, but it's 8 minutes just for that. Release builds are even longer, which I'll talk about in a second. That 1 million lines of code number is from a couple months ago, so it's probably more now. But the app, we add more features, you get more code, and you get slower builds. The other big bottleneck on building for us today is that most of our code is in 2 main Gradle modules, and we've not yet spent the time. We're waiting for Android Gradle plugin 3.0 to start modularizing and getting faster builds that way. But the other thing is, if we're releasing more frequently, we want our members to be getting only the data that they actually need for their device. We want to keep our APK size small. We want to make sure that we're only shipping the images and native libraries that we need for the app. So we are using Google's APK splits. If you thought one release build was slow, building all 30 combinations of screen density and CPU architecture and universal builds that we need is taking roughly 35 minutes for us right now with our flagship app. That alone is almost 20% of our 3-hour time period. And remember, 3 hours is the upper bound. We would ideally like to be much faster than that. So one thing that we did pretty quickly as we started looking at enabling APK splits is figure out a way to do distributed builds with LinkedIn's pipeline. So each build today uses 2 CI machines. The first one will build our debug and test APKs and run all of our tests. And then the second one will go build our APK splits, which currently, so our total build time is gated by whichever of those two is longer. Today, that's the release builds. But I'll talk more about that in a minute. But it is faster. It's certainly faster because we don't have to do those sequentially, but it does require twice as much CI hardware. I'll talk in a second about testing, but at one point we were using up to 6 machines per build to get the speed that we were looking for, which was great for us, but also our CI lab admins were not very happy with us at the time. They're already not very happy with us that we're building 30 APKs and publishing almost half a gig of data for every commit. But looking forward at build speed, we're very eager for Android Gradle plugin 3.0. Just with no code changes, no modularization, just upgrading the plugin with the latest betas, we're seeing 40% faster clean builds, which we are very excited about, and also very eager to start modularizing the app code and get even quicker builds. If you're starting a new app, that's something you should be thinking about from day one. If you're looking at a legacy app, start thinking about how to modularize your code as well. The other thing that's super exciting to us that was announced at Google I/O this year is the Google Play app signing, which gives the option, I think I'm not sure if it's fully available to everyone yet, but it will give Google the ability to generate APK splits for us. We would just need to build the universal build. They will reconstruct the splits on their side, which would be quite a big speed up for us today as well. So for testing, I noted on that other slide I listed unit tests, layout tests, and scenario tests. You may be wondering what those are. Unit tests are exactly what you would think, traditional unit tests, either from the pure JVM or Android instrumentation unit tests. But the more interesting ones are, so we have layout tests, which is a name we made up, but we treat them as unit tests for views. We'll take our layouts, usually a cell inside a recycler view. We'll inflate it in a dummy activity with dummy data. The developer will define like super long strings, super short strings, strings with special characters, populate them in their views, and we'll use the Espresso view assertions checks to make sure there's no overlaps. We'll run all of these tests in left to right and right to left layouts to make sure that there's not overlapping views, buttons don't go to 2 lines in longer languages. And this gives us a reasonable way to check that our views are robust during our CI pipeline. So scenario tests are the interesting ones. These are closer to your integration or end-to-end tests. They all use mock data from a fixture server that's running on the device. And these are usually flows that span multiple screens of the app. These are not an exhaustive suite of everything you can do in the app. And I'll talk a little bit more on the next slide about how we choose what those are. But the idea is that these are the tests that validate that our key business metric flows in the app are still working properly. So a common question that I get is, how do we measure coverage with this system? Every time a new developer joins the team or a new manager comes, they'll want to know, what's my team's line coverage? We explicitly choose not to measure that. I have a feeling it would be not as high as people would want it to be, and that's one of the reasons we explicitly choose not to measure it, because that's not an important thing for us. That's not one of our goals. We want, like I mentioned earlier, we want high value and low maintenance tests. And so for each of our feature, the way we figure out what scenario tests we want to write, we figure out what flows have the highest impact on the business. So then we covered the happy paths of those flows with scenario tests. So as an example, sharing a post to your LinkedIn feed, this is something that if it's broken, this is a really big deal to us. That's like a P0 bug fix that we would want to get out. So we make sure we have a scenario test that makes sure you can go through the path of clicking the share button, typing your post, making sure it gets posted, make sure the right network calls get made, the right cache calls get made. and that the share shows up in your feed. Now, the edge what is maybe more of an edge case, sharing a post over 10,000 characters long from your phone that shows the correct error message when it fails, we don't have a scenario test for that. The team will probably write a unit test for their character counting logic or their error displaying logic, but that's probably not the level that needs a full-on integration test with espresso clicking things and typing text. That's kind of the philosophy we use, which takes some getting used to for a lot of developers. But the way that teams measure their coverage is they think about what are all our key flows, and do we have active and running tests that are covering all of those key flows. The active and running part is an interesting qualifier, which I'll talk about in a second as well. So already the question was asked about speed. Today, and again, this was a couple months ago when I pulled these numbers, but we were running over 6.5 thousand tests per build. This includes unit tests, layout tests, scenario tests, includes running things in left to right and right to left. And we run all of these twice. We run before the commit is checked in and after it's checked in, just to make sure that bad code doesn't even get into trunk. Any change that doesn't pass all of these tests is automatically reverted, and the developer will need to go follow up and fix and retry their push. Our initial approach when we started out was we had one emulator per CI machine. Unfortunately, that emulator was also pre-deployed on those CI machines by our lab admins, so if we ever wanted changes to it, our lab admins had to go make that change across all of the machines. We've gotten a little better since then, but this is what led to our using 6 CI machines per build, because our test times were getting longer and longer, and we needed to go faster. So the only way we had at the moment to go faster was just to throw more hardware at the problem. This got to the point where it was untenable. So we ended up developing a custom Gradle-based test harness. We also saw a lot of problems with flakiness and with the test infrastructure being flaky. And we currently run up to 16 emulators on one CI machine. We were able to go from running our tests on 6 machines to just one, with running them in parallel. We also, it's kind of bleeding into my next slide, but there's a screenshot of locally running 16 emulators at once. If that's not something you've ever done, it's pretty fun. But yeah, like I mentioned, we were having a lot of problems with stability, especially in the test infrastructure. As if you're familiar with how Android runs tests, it will start your apps process, run all of your tests, and then stop your apps process. We had a lot of problems with tests not cleaning up after themselves, with one test crashing and then not running other tests. The new Android test orchestrator library helps to fix some of this. It was not available when we were running into those problems, so we wrote our own solution. For deploying emulators, we have our own custom code now that creates and starts emulators on the fly. It also caches the first launch of the emulator to make sure that every subsequent launch is faster. A lot of the stuff on this slide could be its own hour-long talk, so I'm going to go through at a super high level. And I've given some other talks on some of this stuff before as well, and there'll be some links at the end to those. But yeah, Test Butler is another library that we created and then subsequently open sourced that helps keep the emulator stable by suppressing crash dialogues that show up from other apps crashing in the background on the device. And gives you more control, so your app can do things like disable animations or grant permissions without having to actually add those permissions to your debug app. Let's see. So the important goal of all of this was that we wanted to make sure we had a stable test suite that developers could rely on. If a test passed once and no code changes are made, it should pass forever. So as a quiz, if we have 1,000 tests, each of those tests are 99.9% reliable. What is the overall reliability of our test suite? What's the probability that this entire suite will pass? How many people think it's A? I'm not going to go through all of them because this is a trick question, but 36.7% is the reliability. We struggled a lot with this. We would say a test would fail. It would cause the entire build to fail. The person's commit would get reverted. And the owner of that test would say, I can't reproduce it. I run this test 100 times on my machine. It works every time. I can't get this to fail. So we said, well, it's not good enough if it passes on your machine. It needs to pass every time consistently forever. And we ran into a lot of problems where it was the test infrastructure that was flaky. And it came down to essentially my team to prove that it wasn't the test infrastructure that was flaky. I think we've gotten to the point now where it's been, I can't remember the last time. It's been several months since we found a problem that ended up being the test infrastructure being flaky. So that's a win. But the realization we were coming to is that flaky tests are worse than not having tests at all, because people would just say, oh, that test is always flaky. Let me try again. And they would just re-push. And then what's the point of having the tests if they're not catching real issues for us? So we can fix the test infrastructure. We have fixed the test infrastructure for the most part, but there are still flaky tests. People still write tests that don't do proper threading in their production code. They don't register idling resources when they should with Espresso, and their tests are flaky. So we developed a system, and we had this problem on both Android and iOS. And we developed a system we called Trunk Guardian that is a service that runs in our pool of CI machines. It will constantly monitor what is the usage rate of our CI machines. So if there's 70% of our machines are not doing anything, it will go use some of that open capacity to take the last known good build of our Android app and our iOS app, rerun the tests. If any of the tests fail, and remember this is our last known good, so these tests have passed before. With no code changes, it will rerun them, and if any of them fail, it will make an automatic commit that will ignore that test, open a Jira ticket for the test owner, and say, hey, this test failed. Here's the log cat. Here's the screenshots of what happened. Here's all the CI build logs, and you need to go do something about this. The owner's team is then responsible for going and following up. We do not allow people to just blindly re-enable the test. We will often come and people will say, well, I ran this commit 1,000 times, or I ran this test 1,000 times, and it still passes. It's like, great, but why did it fail? If you can't tell me why it failed, or you can't add some extra logs, or add some extra debug info, or add something to the code that if it fails again, you will be one step closer to figuring out why. So we require either you find and fix the root cause, or you've actually added some more information so that next time you're closer to finding the real issue. And a super important thing here is a daily report goes out to our leadership, all of the VPs and directors, that says for each team, for their team, what is the percentage of their tests that are currently disabled? Because otherwise, the primary concern people have with the service is, well, it's just going to run, all my tests are going to go away, and now I have no coverage anymore. So we needed a way to make sure that developers and teams are prioritizing actually fixing these tests and writing stable tests. So we additionally auto-block any new commits from teams that have had more than 10% of their tests disabled. So by the time you get to 10%, that's pretty bad. That's 10% of your coverage, which is already not a full 100% suite, is not running anymore. So, okay, I put this here because I'm going to grab a drink of water. So, in terms of distribution, so what we call alpha is really just our latest successful build. So this is the last build that's passed all of our CI pipeline. We originally were trying to stick super closely to our actual 3x3 release every 3 hours metric, and we wrote automation that would auto-upload to the Google Play Alpha channel every 3 hours the last known good build. And if you're wondering, you actually could release to Google Play every 3 hours. every hour seems to be too much for their threshold, but every 3 hours works. We actually stopped doing this because we found that the people that wanted builds that fast wanted them actually even faster. They wanted to know, did a developer check in the fix that I was waiting for? If so, give me the build right now. I don't want to wait 3 hours to go get it. So we added a button inside the app that every employee can see that they can just download the latest build at any time. And that's worked out a lot better for us in terms of getting builds to our employees. But for beta distribution, what we're currently doing, this isn't what we started with, but what we're doing right now is we have a Google Play public beta program. It has open membership, but it also has a cap set. So if any of you try to go join the public beta for LinkedIn right now, you'll probably find it's full. But we picked that cap at a number that if we release a beta build that was crashing on launch for everyone who ever downloaded it and ran it, it would not have a material impact on our business. So we did set a cap there that way, kind of to give us a safety net for this. We do 3 beta releases per week right now on Wednesday, Friday, and Monday. I don't know why I wrote them in that order. But it should be Wednesday, Friday, Monday, actually, because our production release is on Wednesday. And when we release to production, we'll pick the latest of those 3, the newest of those 3 that looks good. I'll talk a bit more about that in a second. But our public beta users can and actually do send feedback through Google Play. I was pretty skeptical that anyone would ever send feedback through the Google Play beta program because it's not the most discoverable thing in the world. But anytime that we have had a significant issue that's gotten past all of our tests, that's gotten past our automation and made it to the Google Play beta channel, within 4 hours we've had someone respond on Google Play and say, hey, your API server is sending random language files to my device. That was one of our issues. So yeah, this has actually been really successful for us. Initially, we had internal beta only. And what we found, unfortunately, was that we didn't have that many employees that used Android. So we had a hard time getting the right amount of coverage that we wanted on Android to make sure that we had confidence in our releases. So we had to do 1 beta per week when we were doing internal coverage because it took a week to get enough people to download it and use it to have enough confidence to go to production. Google Play public beta has fixed all of that. Even if this is a small number with respect to LinkedIn, it's still a much bigger number of users that we have compared to employees using Android. So the iOS team is actually pretty jealous now of this public beta program. But for our production releases, like I said, we do once a week on Wednesday. The other nice thing is when we get to our production release, we now have 3 builds that have been used by a large number of members that we know we can monitor how much of the app they've used, what's their crash rate, and pick the newest one that didn't have any blocking issues, that didn't have too many crashes or too many feature bugs. If all 3 of our betas are somehow bad, and this has not happened in a long time, but we will just not release that week, and we'll go hold a postmortem and say, okay, where did things break down? What is the issue we had that made it to, we released 3 builds to a couple thousand people, and we never got any report, but somehow the bug is bad enough to block us from promoting to production. And we had a couple of those. We've made some improvements to the process and haven't had that happen in a while. But the other thing that we can take advantage of is Google Play staged rollout, which lets us, on Wednesday morning, we'll start with 20% rollout, monitor adoption, monitor crash rate, and be able to slowly increase that throughout the day. So this is what our current schedule looks like, where we have a beta release Wednesday, Friday, Monday, production on Wednesday. Our on-call handoff still happens on Thursday. And this adds up to roughly 130 releases per year if you ignore holidays, and LinkedIn has a monthly in-day on Friday where we don't do any releases. Employees can, it's basically a hack day once a month where you can go work on whatever you want. So yeah, this schedule has been pretty great. It is worth noting that when we just had weekly releases still without the 3 betas per week, we hadn't entirely eliminated that mad rush to check in code before the beta cut. But with 3 releases, it seems to have entirely gone away. The nice thing is, as we're ramping features, and again, I'll get to this, as we're ramping features, our product owners can target these beta users as well. So they can essentially within, I think, a max of 72 hours over the weekend is the longest it will take to get a commit in front of actual members that we can see actual crash feedback, actual usage feedback. And that's been super useful and successful for us. I kind of just mentioned it a little bit, but probably one of the primary ways that we minimize the risk in all of this, the risk of having not full test coverage, not full manual testing, is that we have a robust A/B testing and feature flag infrastructure. So most new code, most bug fixes are released behind a feature flag that we can dynamically ramp from our server. And if there's crashing or buggy code, most often it can actually be disabled without releasing a new build. It's just a flip on the server side. And probably the number one question I get, so I'll save that before I go to the Q&A slide, is, but you must have some manual tests. The answer is not really. We do have a team that will periodically test our push notifications and deep links, because those are 2 pieces that are super critical to the app, but also we don't yet have a good way of automatically testing. So they will test that periodically, but also it doesn't block our releases. If they stopped testing it, we would still keep releasing. We don't wait for a sign-off from them before releasing. If they find something, they will raise it, and that will put a halt in the process, but it's not a blocker for us waiting on them. Teams will also do manual bug bashes and manual testing when they write new features, but that also doesn't block new releases, because all of these new features are written behind a feature flag that we just blocks them from turning on that feature flag. And regressions, people don't really do manual testing for that, but we let our tests cover that and our production monitoring as well. So just as a reminder, this is what we went through in our pipeline. And in terms of what we're doing in next steps, and we're constantly looking for ways to reduce this commit to publish time. So this is our time period here between code review and beta release. We want that time to be as short as possible, because it does block, if I'm checking in code that my teammate is depending on, he needs to get that code. It needs to get through this pipeline. So we're looking for ways to make that faster. Our VPs are looking at commit to publish time as a top-level metric that they care about from a developer experience point of view. So there's lots of motivation behind us to make that fast and to do things that will help make that fast. Like I mentioned, Google Play app signing is a super important one that we're looking at, hoping to speed things up, as well as Gradle modularization and the build cache. One thing with emulators, we're running 16 emulators per machine. That's not truly scalable, because as we write more tests, we still just have 16 emulators. We've heard from some other companies that have pools of emulators running constantly that you can use those to run your tests, so thinking about doing something like that as well. Automated performance testing. We do have production monitoring for some kinds of app performance, but we don't have a great way currently of catching UI performance issues before they get to production. Like I mentioned, push notification and deep link testing, as well as automating our monitoring of Google Play reviews, are all things we're thinking about as next steps. But other than that, the other thing is people will say, that's great for LinkedIn. That's not really realistic for my company. Keep in mind, it has taken us 2.5 years to get to this point where things are running as smoothly as they are. And also, it's super important that your leadership and your, from the highest level, this is a mindset shift, and it really helps if it comes from top down. And start with the simpler pieces. Anybody can add static analysis. You can write lint checks. You can enforce the lint checks that Google provides, or set up tests to run in your CI builds. But with that, I think we have 5 minutes left for questions.
Yeah.
Yes.
My question is more on the sort of macro process side. Like leading to this, I'm imagining you mentioned 200 developers. There have to be 200 simultaneous balls in the air. So from a product management perspective, how many do you have looking at the project? And it might have a fantastic side effect because the product owners typically have a mindset of, I want these features in this release, right?
Yeah.
That's the classic model. And if you have that much going on, that many balls in the air, they have to sort of fundamentally let go. So I wonder if the size of the team was sort of driven to force their mindset shift, or how that actually went about, because that's really interesting to me.
So that's a good point. I should explain a little bit. The way that our flagship product is set up is, from an organizational perspective, we have a feed team, we have a search team, we have a messaging team. My team is actually the Android, or the flagship infrastructure team. So we're kind of the hub looking at these things more centrally. But for the most part, the feed team cares about the feed product. And their product managers, they have their own product managers, their own designers that are looking at their feature rollouts. The other nice thing about this system and feature flags is that, for the most part, ramps of features are decoupled from releases. People will check in half-finished code all the time, and it'll just be behind a feature flag. And the product manager is really just waiting for the full feature to be in, and then they can choose when they ramp it. Does that answer your question?
I think so. So I'm envisioning that it's effectively you've embraced Kanban from the inside.
Essentially, yeah.
Yeah. Okay. That's it for me.
Yeah.
Can you talk about what tools you use? Thank you. What tools you use for continuous development? And secondly, you mentioned that your application is, with each release, getting bigger and bigger. Do you have some cap that you make so that it doesn't get too big?
Yes. So most of our continuous integration is custom. Like LinkedIn is big enough that we have our own team managing our pool of dedicated continuous integration servers. So I don't know how much is useful to share there. But in the idea of capping app size or capping number of features is one that's at the top of our mind right now, because we are trying to figure out, how do we prevent this indefinite growth? How do, from the product side, we decide what features are not being used or need to be cut out? I don't think we have a great answer for that yet, but we're exploring ways of measuring, ways of keeping track of how much code is the feed team adding versus the search team versus the messaging team versus how much value are those teams bringing back to the business from the code that they're adding. So we're exploring different ways, but I don't think we have a great solution yet.
So since you moved from manual to fully automated, have you seen any spike in your beta test bug issue reports or anything like that?
I think it's not been the smoothest process always in transitioning. I think now we're at actually a better state than we were with manual testing, but getting started, I think some types of issues we've found out, we can write a lit check for this that then catches it, or a big thing that we've seen is our on-call needing to be very responsive. So we may see a crash in beta. The on-call needs to say, okay, this is a new crash. It needs to be fixed before the next beta release. Or that's when we run into a situation where now all 3 betas are bad. We had that happen a couple times, and there's been some re-education on our on-call teams and expectation setting with feature teams of when a bug comes in from on-call, what's the priority, how fast are you expected to get some kind of fix. And I think things have gotten better. Yeah.
So another thing, so you mentioned that you have like 3 releases per day, and that was to make sure that there isn't enough time for manual testing. But what about using robots or monkeys or robo tests? Do you use any of that?
Yeah, that's actually a good point that I forgot to add to the slides. Another thing we're experimenting with is we have a build machine that is 24 hours a day devoted to running monkey testing. I guess another thing I didn't call out is the tests that we do run. We only run on one API level right now, just because we found for the most part that's good enough. That catches 90%, 95% of stuff. But this monkey testing will run all the API levels we support and just continuously run monkey testing and automatically open JIRAs for crashes that it finds as well.
And could you give a like a high-level distribution of how much time the unit tests take versus the in the integration, right? Because even your layout tests run on an emulator because they're espresso, right?
Yeah. It's somewhat hard to break down. So even some of our unit tests run on the emulator as well. But I think right now we're at like 22 minutes running 7,000 tests across 16 emulators. They all run in parallel, so it's hard to break down unit versus layout versus scenario. But yeah.
Thanks.
Cool.
So what do you run on every PR versus every 3-hour release? Or do you running everything every PR?
Everything, every commit. Yeah.
All right, good.
Yep. Because the goal is to be able to take any commit at any time and immediately release it. Sorry, what was that?
Like, what about like the integration test? Like, is it also will be performed in parallel?
Are the integration tests run in parallel? Is that what
Yeah.
you said? Yes. So all of our types of tests are run in parallel across 16 emulators at the same time.
Do you face any problems with the emulators, like with the real devices?
Sorry, what was that?
Any problems with the emulators which differ from the real devices?
Emulators versus real devices, is that what you're asking about? We don't currently run anything on real devices. We don't have a lot in our app that would be different on real devices. We don't have a lot of native code. We don't have a lot of areas where we're concerned about that. We do have a real device lab at LinkedIn that we can use for other types of testing that we're exploring now, but nothing super concrete yet. Cool.
Thank you.
For the release every 3 hours, you said developers like it better. I'm just wondering if that's because, let's say they get up in the morning, they start working on the feature, they think, I'm aiming for that 10 a.m., and it comes to almost 10 a.m. and they say, I'm not really ready, no problem, I'll catch the 1 o'clock, so they feel less pressure and they can do a more finished job. Is that the reason?
I think so, yeah. And people tend to think about it more in terms of the builds going out to people other than employees, which you can view that as a positive or negative. But even that now we're down to it's every 3 times a week. So yeah.
So do you use the same data for all 16 parallel testing?
So we don't run the same tests multiple times, if that's your question. So we have 6,000 tests. We'll split the 6,000 tests among 16 emulators.
Okay.
Does that answer your question?
Yeah, I'm just asking, like, you're using same data, so is there any data dependency, like if you are using all 16 simulators at the same time, right? So you are using same data all 16 times, or it's a different data?
What do you mean by same data?
Same data, I mean data types, all this data, like you are passing the data, right?
Yes. So all of our tests will use mock server responses from a local fixture server.
Oh, so it's all,
Yeah.
okay.
Okay, guys, last question.
Do you run all your tests on mock, or do you run in real-time environment like QA or?
So every test that runs in our CI pipeline and could block a commit is mock data.
All mock data?
All mock data, yes. Yeah. We did experiment with having some tests that ran against a QA server offline, not as part of blocking the commit.
Mm-hmm.
They were actually super hard to maintain. They never caught anything, and we ended up removing them. But,
Okay. Thank
but yeah, cool. Thank you very much.
Thank you.